In this video, we're going to look at solving some more trigonometric equations. So we need to solve 4 cosec squared theta minus 9 equals cot theta with the range of 0 to 360. So the first thing we ought to do is to make these the same. Well, I know there's a trig identity that states that cosec squared theta is identical to 1 plus cot squared theta. And what I'm going to do is use that here. So I'm going to say that's the same as 4 multiplied by 1 plus cot squared theta minus 9 equals cot theta. So we've got 4 plus 4 cot squared theta minus 9 equals cot theta. So what we've got here is 4 cot squared theta minus cot theta minus 5 equals to 0. So now what I'm going to do is use my calculator to solve that. Put an alpha and minus. I'm going to use polynomial. It's a quadratic, so polynomial degree 2. Put the coefficients in, 4 minus 1, and we've got minus 5. So the first solution will be cot theta equals 5 over 4. So I could write cot theta is 5 over 4, or cot theta, we get our second solution now from the calculator, that is minus 1. So we need it in terms of tan theta, so it's the reciprocal, so tan theta is 4 over 5, or tan theta is minus 1. So what we can do now is we're working in degrees mode, so we can do theta is arctan 4 over 5. Get that on our calculator now. So we can do arctan 4 over 5, which is 38.7 degrees. Then we're going to use the cast diagram to work out the next solution. So tan is positive here, and it's positive here. 38.7. So the next solution you want is this. So it's going to be theta is 180 plus 38.7 which is 218.7 degrees. So I know that when I do arctan of minus 1, I'm going to get minus 45 degrees. So we use the cast diagram again. But now we say, where is tan negative? Well, it's negative here in this quadrant. Put 45 degrees. It's negative in this quadrant. So the first solution is theta is 180 minus 45, which is 135 degrees. And the next solution is here, 360 minus 45 degrees is 315 degrees. So my solution set, therefore my solution set is, so in order of magnitude, it would be 38.7, followed by 135 degrees, followed by 218.7 degrees, followed by 315 degrees. So the next example is for you to try. You can pause the video, and when you're done, I will go through my work solution. Okay, welcome back. So here we're going to use a trig identity that sec squared is the same as 1 plus tan squared theta. So sec squared theta is identical to 1 plus tan squared theta. So I'm going to use that here. So 1 plus tan squared theta is equal to 3 tan theta. So we could write that as tan squared theta minus 3 tan theta plus 1 equals 0. So we can type those coefficients into our calculator. So menu alpha minus polynomial, and we can say 1 minus 3 and 1 again. So my first solution is going to be 2.61. So I'm going to say tan theta is 2.61 something. And then what I'm going to do is store that in memory. So I'm going to press store and A, that's stored in A there. And then we need my second solution, which is tan theta equals 0.381, and so on. So we're going to arctan both of these values. So let me store that in B. So we're going to arctan both of these. So it's going to be arctan of A, and that gives me 69.1 degrees. So use cast diagram again. Tan is positive here, it's positive here. So ASTC. So 69.1 degrees, 69.1 degrees here. And then this is the solution you want. So theta 180 plus 69.1. (249.1 degrees to 1 decimal place). So now we can do the same for this thing. So theta is arctan of the value we had here, which is 0.381. We stored that as B. So in our case, arctan B, so 20.9 degrees. Just double check that. Yep. So again, use the cast diagram. Same thing. Positive here, 20.9 here, 20.9 there. ASTC. The other solution one is this. So we're going to say theta is 180 plus 20.9 degrees, so plus 180. So we get 200.9 degrees. So we can say our solution set, therefore our solution set is so in order of magnitude it's 20.9 degrees followed by 69.1 degrees followed by 200.9 degrees followed by 249.1